First part of that chapter 16 on amine, narrated lecture. Now we're bringing here another atom. This is nitrogen, start with an N. Learning objective, identify, classify those amines as primary, secondary, or tertiary. Well, those amines are organic derivative of ammonia. Ammonia, you should know the formula NH3, that's a gas. General formula is R, can be any organic compound, NH2. R2NH and R3N, we're going to see those. First one will be a primary, second one secondary, and tertiary for the third example. And this has to do with how many organic groups are individually bound directly to the nitrogen atom. So what you need to know about the nitrogen atom is that it can make no more than 3 covalent bonds. We talk about carbon for covalent bond, where nitrogen has 3. The simplest on the left is ammonia, 1 nitrogen and 3 hydrogen. Second example is a primary amine, general formula R, that just represents whatever organic compound, NH2. Example below, CH3, CH2, NH2. Secondary amine when you have 2 organic compounds attached to the nitrogen and then you have only 1 hydrogen, so R2NH. Example, twice CH3, CH2 attached to the nitrogen and 1 oxygen. And a tertiary amine will have 3 organic compounds starting with a carbon atom attached to the nitrogen. Example below could be CH3, CH2, so 2 carbon atom ethyl 3 times attached to the nitrogen atom. How to classify them? Well, you have to also see that the lone pair of each amine nitrogen is responsible for most of the chemistry of the amine. When you have a fourth group bound to the nitrogen through its lone pair, then you have what we call a quaternary ammonium ion, permanent positive and form ionic compound. Example right here, R4N plus, positive, there will be a cation. So how do we classify them? Well, it depends here, their name and classification. Being able to name them, primary alkyl amine RNH2 are named by identifying the alkyl group that is attached to that nitrogen atom, adding the suffix amine to the alkyl group name. Some example right here, I see that I have 2 carbon atoms on the left, so that's the ethyl, and then you have NH2, so the name becomes ethylamine, all attached. Middle example, I have a carbon atom and then 2 CH3 on each side, so it's an isopropyl attached to an amine, so the name will be isopropylamine. And then you can even have a cyclohexyl, so 6 carbon atom in a cycle, that's a cyclohexyl, attached to NH2 is a cyclohexylamine. Non-heterocyclic secondary or tertiary amine are named by adding di or tri to the alkyl group and with the same suffix amine. So those are examples. Here on the very far left, I count on the left side 1, 2, 3. I'm going to be a propyl. Far right, 1, 2, 3 carbon atom, another propyl, so I see 2 propyl, so it's a dipropyl attached to a nitrogen and hydrogen, it's a dipropyl amine. Third example, there would be a tertiary amine. I have 1, 2, 3 times CH2, CH3, ethyl, so that is a triethyl attached to a nitrogen, triethyl amine. Sometimes the R group in the secondary or tertiary amine are different, and then you name those compounds an N substitute derivative because they are attached to the nitrogen atom. Parent compound is the one that contains the largest of the R group. Every other group are considered to be N substituents. So here on the far left, I see on the very far left of the example that I have 2 carbon atom alkyl, so that would be ethyl, attached to the nitrogen, so it's an N-ethyl. And then on the right side, 1, 2, 3, propyl, which gives my name propylamine, so it's an N-ethyl propylamine. Far right example for a tertiary amine, I have 2 times a methyl, so that's a dimethyl. Both of them are attached to the nitrogen atom, so it's a N, N dash dimethyl. And on the right side, the longest carbon atom, CH2, CH2, CH3, propyl, attached to nitrogen propylamine. So it's a N dimethyl propylamine.